This summer, I have been working with Dr. Whitmire on a research project to determine the occurrence of microplastics in alligator scat. Microplastics are small particles that are either manufactured or broken down from larger plastics and can enter the environment in many ways. They can be consumed by the alligators directly or indirectly, like eating a contaminated animal. Consuming these plastics can sometimes be fatal to smaller animals, but not many studies have looked at how these plastics affect alligators. My main objective this summer was to develop a procedure to extract microplastics from the alligator scat. I began by reviewing published methods and working from preliminary work done last year to develop our own protocol for alligators, while Dr. Rainwater collected samples from locations along the South Carolina coast. We have been able to develop a protocol that works well for separating these plastics from the alligator scat. The protocol involved digesting the organic material using chemicals such as potassium hydroxide and hydrogen peroxide. Since plastics have a low density and can float, we used density separation to separate the plastics from the material that was left after digestion, which I then collected on filters and counted under a microscope. We found several plastic fragments and fibers in each sample, mainly transparent in color, but occasionally blue or pink. We worked diligently to prevent contamination in our work area and samples, but this ended up being more difficult than I anticipated. Even with taking measures such as using glass pipettes and beakers and covering samples with tinfoil during digestion, I had contamination problems in the first couple trials. One of the metal tools I was using had rust on the inside that got into our samples, which I solved by switching to a glass tool. I also learned the hard way that you cannot add too much hydrogen peroxide at once because the sample will react strongly and bubble over. This research is addressing the rising plastic pollution seen in our oceans and rivers and examining how it affects the wildlife on the coast. We are working in a non-invasive way to examine the amount of plastics alligators consume. We have chosen to work with alligators for two reasons: their molecular similarity to that of humans and other mammals, and their role as a top predator in the coastal system. Knowing how plastics move through and affect an alligator's system can help us start to understand how these contaminants might also affect humans, especially those who eat fish, alligators, and other coastal animals. The alligator's position at the top of the food chain in the coastal system also helps us understand how these plastics can travel through the food chain and potentially end up in humans. By educating the public and sharing this information and future research on microplastics, we hope to begin influencing those around us to be more attentive of preventing and picking up litter, less reliant on single-use plastics, and more demanding of officials to create policies surrounding the production of microplastics on everyday items.